Analyzers of Mathematics, welcome back to Chapter 6, Lesson 9 notes. This is review. We have already put our quadratic functions in vertex form prior to now, but again, we need it, so let's talk about it again. What we're going to do here is I'm going to just go quickly through all of the practices because we've very recently completed the square multiple times, and we have very recently already analyzed vertex form of our quadratic functions. So I'm just going to kind of go through all these examples and show you where I'm getting things from. Okay. So the first thing we want to review is just completing the square in general. Okay, finding that C term means taking the B term when x squared is all by itself, a 1 in front of your x squared, dividing it by 2 and squaring it. Okay, why did I make that distinction? Well, here it's nice and easy, right? B term, x squared is all by itself already, right? It's 1. So take this, divide it by 2, and square it. So 16 divided by 2 is 8. 8 squared is 64. So x squared plus 16x plus 64 is a perfect square trinomial. Okay. New color for the middle term. The reason being x squared is not alone here, so I cannot just go to the b term. I have to first divide by 3. Okay. Obviously, I would normally divide that by 3 if it were a number, but that's where I'm filling in, so that's not a number yet. Okay. So here we get x squared plus 6x plus c. Now take 6, divide it by 2, and square it. That's how you get c equals 9, and your whole quadratic is x squared plus 6x plus 9. If your b term is odd, square it and put it over 4 for your c term. Okay, because an odd number is not going to evenly divide by 2, so it's not going to give you an integer. But 2 squared is always going to be 4 for your denominator. And now 7 squared is 49. So x squared plus 7x plus 49 over 4 would be my perfect square trinomial. Now we're going to solve by completing the square, and I'm going to make this quick because we've been doing it so many times. Okay, so this is going to be quick work here. I'm going to subtract that 17 over and leave a plus blank, and then put a plus blank over where that 17 is. I just did this, fill in the blank with a 64. 16 divided by 2 is 8. 8 squared is 64. Now this is a perfect square trinomial. It factors to become x plus 8 in parentheses squared. Meanwhile, if you don't know off the top of your head, let's just do it, but you probably should, right? 64 plus 17 is 81. Now you take the square root of both sides because you completed the square so that you could take the square root of both sides so that this x plus 8 would come out. Over here, it's plus and minus 9 because 81 is a perfect square. The square root of it is 9. We always put that plus and minus in when we take our own square root of both sides of an equal sign. And lastly, we subtract this 8 over to get x equals negative 8 plus or minus 9, which of course is 2 integers. Negative 8 plus 9 is 1, and negative 8 minus 9 is negative 17. That's my answer here. Negative 17, comma, positive 1. Sorry. Over here, start by dividing everything by 3. So x squared plus 6x plus blank equals, let's see, 90 divided by 3 would be 30, right? Plus blank. Fill in the blank. 6 divided by 2 is 3. 3 squared is 9. And so this is a perfect square trinomial. So it factors to become x plus 3 in parentheses squared. Over here, 9 plus 30 is 39. Take the square root of both sides. This time it's not a perfect square on that side. So x plus 3 equals plus and minus radical 39. 39 is also not divisible by any perfect squares. And subtract that 3 over, it always goes in front of the plus or minus. When you subtract that number over, it always goes in front of the plus and minus. And of course, that is 2 irrational answers for our roots, right? Negative 3 plus radical 39 and negative 3 minus radical 39. Now, I reminded you how to find the C term and how to complete the square. We're not going to go through the entire process of completing the square and getting a final answer for roots when we convert. We're actually just going to do the basic completing the square piece so that we can make a binomial squared, okay? That's the only piece we really need for switching from standard form into vertex form, okay? And the reason I like vertex form is if my whole goal is to just find the axis of symmetry in vertex, you see those numbers right in the equation of vertex form. So it just makes life easier if that's the goal, okay? Now, this is a repeat of the exact notes we already used back in chapter 2, okay? So these exact notes are the same. I am going to state this process out loud as I go, okay? So as I go through the examples, I'm going to do that. These are new examples, okay? We're going to do those again. And then afterwards, once I have some quadratic equations in vertex form, I'm going to show you how to convert back. I'm also going to show you how to use your graphing calculator to check your answers. I always check my answers just to be sure I'm doing it right. Okay. So let me start with exercise 3A. Okay. And the first thing I want to do is I want to move the number 59 to the other side of the equal sign. Okay. So I've got a negative 59. I'm going to have to add it to both sides. Now, y and 59 are unlike terms, so just rewrite them. Y plus 59 equals negative x squared minus 14x. Now, the other issue is there's a negative in front of the x squared. Now, that's going to need to be back in the end, but right now I can't have it. So let's divide everything by negative 1, which just means all signs change. So negative y minus 59 equals positive x squared and positive 14x. And now I can put my plus blank on each side. The blank gets filled in by the completion of the perfect square, right? I need to make this a perfect square trinomial. 14 divided by 2 is 7. 7 squared is 49. That's what goes on the blanks. This is now a perfect square trinomial. So that factors into one binomial squared, and that one binomial is x plus 7. Okay, think of it this way. We're getting this by taking the middle term and just dividing it by 2. Now over here, meanwhile, these are numbers and can add up. 49 minus 59 is negative 10, and you've still got your negative y. Okay, now we're going to slowly move things back. Okay, now that I've got my binomial squared, I move things back to get only a y on the left. So I'll start with adding 10 to both sides and put that at the back behind the binomial. So negative y equals x plus 7 in parentheses squared. So plus 10 at the end. And then, of course, the negative has to go back. It's just going to change the signs around the binomial. Once you've got the binomial squared, it itself doesn't change. What's inside it doesn't change. Now on the outside, yeah, it's going to become, so we're dividing everything by negative 1. It becomes a positive y, a negative in front of the binomial squared, and a minus 10 out here. Now we also needed to now state the axis of symmetry and the vertex or turning point. So your axis of symmetry is always x equals, and it's always the opposite of what's inside the parentheses. And your vertex is the opposite sign for the x, the correct sign for the y. That's the pieces that we're going to check using our graphing calculator. Okay? So here's how we're going to check it. Ready? I'm going to make my graphing calculator a little bit bigger so you can see my screen. Let's go to y equals, oh, got to delete those guys from a previous lesson. In y1, I'm going to plug in the original, which was negative x squared minus 14x minus 59. Remember, when you're plugging in a number that starts with a negative, it's always the little negative under 3 to start. Any minus is actually the minus sign here. Okay. Now what I'm going to do is I'm going to arrow down and I'm going to put the new form that I just found and graph them, and hopefully they end up being exactly the same graph, because these should be exactly the same quadratic function, just one in standard form and one in vertex form. And this is how I check to make sure I have the right answer. So negative x plus 7 in parentheses squared minus 10 on the outside. Now, notice they both have a negative a value, right? Because that's still the a in front of the x squared always. So that is still the same. And then it's the either b or c or h and k, depending on which other form you have. So when you press graph, you see, oh, neither. Yikes. I bet that means since my x of symmetry was x equals -7 and my vertex was -7, -10, bet that means that this is a parabola that never touches or crosses the x-axis. So let me just window and change this to 20 and change this to 20 and this to 20 and this to 20. Oh, how about 20? I did that wrong up here too, just so I can see this. Ah, there it is. Look at that. Quick blue, then quick red. Notice they cover each other. That means I've got the same parabola. What this now means when I go to graph this, if I were going to, is press second and graph to see the table of points. And I just want you to look, the numbers are exactly the same because these are exactly the same parabola. But look at this. Axis of symmetry is x equals -7. Turning point is -7, -10. Okay, so that's how we'll check our answers. That's how we'll check our answers. We'll do it this way. Make this guy smaller just for a sec and get into this one right here. So B, question B, move this over. There is no C term to be moved away, but there is a 2 in front of the x squared. So we have to start off by dividing everything by 2. That includes the y because it is everything. And that's because you need to have a 1x squared here. But this 2 that's under the y, it's just a placeholder. It's just hanging out under the y until I'm done completing the square, and then I can multiply it back through. So it just hangs out here, and it gives me a plus 4x here. Now, what that also means is now my plus blanks can go on each side because I have only a 1 in front of my x squared. 4 divided by 2 is 2. 2 squared is 4. That goes on the blanks. Don't worry about this. They're unlike terms, so don't worry about it. Now, this is a perfect square trinomial, so it factors to become 1 binomial squared. Of course, that 1 binomial is x plus 2 because 4 divided by 2 is 2. Now, over here, I've still got all this stuff, but now that I've got my binomial squared, these things can start to come back over here. So I'll start by subtracting the 4 over. It just goes at the end. Y over 2 equals x plus 2 in parentheses squared minus 4 at the end. And now, to get this 2 back over, I multiply everything by 2. Okay, so that means everything here. So that I get y all by itself. That just means the 2 is now the a value that it originally was, going in front of my binomial squared. Because once I've got my binomial squared, it itself doesn't change. Everything outside around it does with those things you move back from y. So now I've got a -8 out here. Okay, that means that my axis of symmetry is x equals -2, and my vertex or turning point is -2, -8. And I do know this is a smiley face parabola. We knew this one was frowny face because it was a -a value. This is a smiley face parabola, also a little narrower than our typical. But if we want to check our answer for it, scooch this over. Oh, sorry, I have this underneath. Scooch this over and make this bigger, and let's plug both of these into y equals. So let's delete these guys, clear them out, and in y1, let's put the original, which was 2x squared plus 8x. So there's the original. Arrow down to y2, and let's put our new. So 2 times, in parentheses, x plus 2 squared and then minus 8 on the end. And when you press graph, these two things should just immediately overlap, which they did. Now, to check our axis of symmetry in vertex, press second and graph, even though I could see it there. Still, look at all those are the same. All those are the same. All those are the same because they're the same parabola. We want to check that negative 2, sorry, I went too far. Negative 2, negative 8 is the turning point, and look, it is. That means that x equals negative 2 is the axis of symmetry. There we go. Now, if I am going backwards from vertex form to standard form, okay, I check it the same way using the graphing calculator, but basically all I do is FOIL, okay? All I do is FOIL and then combine like terms. This is easier to go back the other direction, all right? So A here, start by foiling. So I'm just going to replace, well, not even going to worry about it yet. 2, and then this is really x minus 3 in these two parentheses times itself, and then plus 1. And so I FOIL first. X squared minus 6x plus 9. Now I distribute the 2. Whoa. That's a 12. Why was I saying 8? That was weird. Adding instead of multiplying, I suppose. Minus 12x plus 18, and then we add 1, and you get 2x squared minus 12x plus 19 is the same quadratic. And we check that by y equals. Notice how much quicker that was, right? 2 times x minus 3, parentheses squared, and then plus 1 on the end. And then our new, which was 2x squared minus 12x plus 19. And press graph to make sure that they match. There they are. One more. So I'm going to FOIL first, of course. So let's see. I've just got this, and then I just rewrite as binomial times itself, because that reminds me that it's FOIL. It's not just square both, right? That's not what it is. And if it were, maybe it would make things easier, but it's not. So you got to FOIL. So rewrite it so you remember that. So now I distribute. So let's see. We get x squared plus 4x plus 4. And then we distribute a negative, so all their signs change. And then 4 minus 4 at the end is a minus 8. So that should be my new equation in standard form. So let's check that out. All right, let's check that out. Make sure that that is correct. Y equals, so let's start with the original vertex form, which was negative, so the little guy under 3, x plus 2 in parentheses squared, and then minus 4 at the end. And then our new guy should be negative, the little guy underneath the 3, x squared minus 4x. Oops. Hello. Try that again. I was down here. Pressing the wrong buttons. There we go. Minus 8, and graph to see it. Got it. Yeah, that's it. And again, this is a review. We've done this before, but use the notes to help you with either direction you are asked to go. So you should be able to convert any function, any quadratic function, from standard form to vertex form, or from vertex form to standard form if asked to do so. Good luck, guys. That was the end of the middle section of chapter 6. So we will stop and review and have a quiz on this. Parabola properties, right? That's where we're at this time. Okay, guys. Good luck. Let me know if you need anything. I'll be seeing you soon. Bye.